Hi, welcome to Photon Academy. In the previous session, we have seen about the multiplication of the vectors, position vector, null vector, etc. Let us see in this session about the resolution of vectors. Let us see about the resolution of vectors. A vector can be resolved or split into components. A vector can be resolved. Resolved meaning is split into the components. What is the meaning of component? A component is nothing but the contribution of vector in a particular direction. So, what is the meaning of the component? Here, component means a vector's contribution in a particular direction. Clear? Now, let us see this by means of an example. Observe. This is XY plane. This is X-axis. This is Y-axis. This is origin. Let us say a force F is acting. A force F is acting an angle theta with respect to X-axis. The force F is acting an angle theta with respect to X-axis. Observe. If this is the force, its contribution along X direction. That means how much out of this entire force F, how much of it is acting along X direction is known as horizontal component. Okay. Similarly, out of this force F, how much is acting along the Y direction? Is known as vertical component. Along Y direction, here I write, along Y direction is known as vertical component. Here, F is a force. If I want to split this force or resolve this force into the components, the meaning of the component is out of total quantity of F, how much is acting towards x-axis is nothing but horizontal component, and how much is acting towards y-axis is known as vertical component. Clear? Now, observe carefully. The component of this force, that means the contribution of this force along the x-axis, that is the horizontal component, I am denoting it as Fx. F subscript x. That means component along x direction. Component along x direction. Similarly, the contribution of this force along y-axis, that means in the vertical direction, is known as vertical component, and it is denoted as Fy, F subscript y, along y direction. Along y direction. Here, that means F force is having two components. One is Fx along x direction. The other is Fy along y direction. It indicates that force F has been resolved into two components. One is horizontal component, the other is vertical component. Or simply, force F is split. It is split into the two components. Horizontal component, Fx, vertical component, F. Is it clear? No. Observe. Let us say this is x-axis, this is y-axis, this is horizontal. And a force F is acting at an angle theta with respect to x-axis. Clear? Now, the component of this F along x-axis, horizontal component is Fx. The component of F along y-axis is vertical component is F. Now, I want to find out what is Fx, how much is Fx, and how much is Fy. I am interested to find out how much is horizontal component, what is its contribution along x, how much is the vertical direction, what is its contribution. I would like to find. Clear? To find out this, simply what I am doing, I am keeping a parallel line. This component is Fy. I want to draw a parallel to this Fy. Here I am putting parallel to this. I am drawing this Fy. Here. So that O A B is a right angle triangle. Okay, right angle triangle, right angle triangle. O A B is a right angle triangle. Clear? Now, in this right angle triangle, okay, if I take cos theta, what is cos theta? adjacent side OA by hypotenuse OB. OA by OB. Adjacent side by hypotenuse. What is adjacent side? It is Fx. OA is nothing but Fx. And hypotenuse is how much? F. It is, this length stands for the magnitude of the vector. That is F. So, here. Okay. That means if I cross multiply, cos theta is Fx by F. If I cross multiply, Fx horizontal component becomes equal to F cos theta. Horizontal component Fx is F cos theta. How the clarity? Okay. Now, observe, if in the same triangle, this was x-axis, this was y-axis, this origin, this was vector F, and this is Fx, horizontal component, this is Fy, vertical component. If I draw a perpendicular, that means perpendicular to the x-axis, this is parallel. Here I am putting parallel such that I dropped a perpendicular Fy on the x-axis. Now, OAB, triangle, OAB is a right angle triangle. In this right angle triangle, okay, what is, this is theta, no? What is sine theta? Sine theta is what? Opposite side AB by hypotenuse OB. Clear? Now sine theta is equal to opposite side AB stands for the magnitude is, this vector's magnitude is, component is Fy by OB. OB is the magnitude of this length, that is the F. So Fy is equal to, cross multiplication gives Fy is equal to F into sine theta. F into sine. This is vertical component. Vertical component of F. That means the contribution, vertical component of F. The contribution of F along y-axis. Clear? Okay. Now, I am summarizing. Horizontal component Fx is F cos theta. Vertical component Fy is F sin theta. Horizontal is Fx. Vertical is F. Is it clear? That means if a force F is given an angle theta with respect to a particular axis, then you can easily find out its contribution towards a particular direction. Here in this case, towards x-axis, horizontal direction, horizontal component was Fx, and vertical component towards y-axis, it was F cos theta and F sin. Is it clear? Okay. Now, observe carefully. Here, A simple thumb rule. Simple thumb rule I am indicating is simple thumb rule is, observe here. This is x-axis origin. This is y-axis. Let us say the force F is this. Let us say it is making angle theta with vertical. The force is making theta with vertical. And observe, whatever the force F and the axis with which it is making theta, the axis with which it is making angle theta, that immediate component, what is that immediate component? Vertical component. That immediate vertical component becomes F cos theta. What is that vertical component? Fy. This vertical component is Fy. Now the clarity, once again I am telling. This is F. F is making theta with vertical. The force with which axis it is making theta, that component becomes cos. F cos theta. Since it is making with vertical, it becomes vertical component. Blind thumb. The other component in other direction, automatically it becomes F sin theta. What is the other direction? Horizontal. That is Fx. Horizontal component is F sin theta. Vertical component is F cos theta. How the clarity? In the previous case, it was the force making angle with x-axis. Now have changed the angle. F is making angle with vertical. Immediate component becomes cos, the other becomes sin. Immediately it is making with vertical, hence vertical component is Fy, F cos theta. The other component is along x direction, Fx, F sin. Clear? No. Observe. I take another example. Let us say this is, let us say this is the second quadrant. This is x-axis. This is y-axis. Second quadrant x bar, negative x-axis, x bar. Let us say the force. This is the force I am taking. This is force F. This force is F. Let us say it is making theta with x-axis. Theta with x-axis. Clear? Force is making theta which axis? X-axis. So x is which direction? Horizontal. So hence horizontal component. Okay. What is horizontal? Fx. So F cos theta. F cos theta. And the other component automatically in the vertical direction. Vertical component. Vertical component. Fy, other direction. F sin theta. Clear? This Fx is magnitude. Direction is towards this. And Fy is magnitude. And direction is upward. Clear? Now, I take another example. Let us say I have taken a third quadrant. This is negative x-axis, negative y-axis, origin, and a force, F, making an angle theta with vertical. Here, making an angle theta with vertical. Observe, force is making with which axis? Vertical axis. Theta is with respect to vertical. So immediate component is what? Cos. F cos theta. That is what? Vertical component. Vertical component stands for Fy. This is vertical. Vertical component. Similarly, the other component automatically becomes Fx along x direction. Horizontal component is F sin theta. Horizontal component. Here, another example I take. Observe. This is x-axis. This is y-axis. Fourth quadrant, let us say. And the force is F. This is F. Here. Now, it is making theta with x-axis, let us say. No. With respect to which axis it is making? Horizontal axis. So, horizontal component will be horizontal component will be what? Along which axis? X-axis. Fx. F cos theta. Immediate theta making axis is cos theta. And automatically the others becomes vertical component F sin theta. F sin theta, it is vertical component. Vertical component. That means this is Fx. This is F. Clear? So it is a basic thumb rule. If a force is given, and if that force is making theta angle with respect to any axis, along that particular axis, component becomes cos, F cos theta. If it is horizontal, then it becomes horizontal component. If it is a vertical, it becomes a vertical component. Clear? Automatically, other will be the, if it is the first one is a side, then it becomes cos or vice versa. Clear? Okay. Now, this is the resolution of vectors into the components. If a vector is given, you can split that vector into the components along the given axis. Along the given axis. Clear? Okay. Now, observe. Let us see. Representation of vectors. Representation of vector. Clear? Now, observe. You can represent vector by means of graphical way or pictorial form. Graphical representation. Representation. means suppose this is x-axis, this is y-axis here, and here let us say a vector f, okay, at an angle theta with x-axis. Okay. Now, the length of this vector, here it is a tail, it is a head. The length of this vector becomes the magnitude. Length of vector is equal to the magnitude. Clear? And the direction. Observe. In which direction it is? O to horizontal. Suppose if I represent as OA, O to A. Direction is O to A. An angle theta with respect to x-axis. An angle theta with respect to x-axis. Clear? Okay. And observe. If you want to find out the theta also, simply what is the component of this force along x-axis? Fx. What is the component of this force along y-axis? Fy. Clear? And if I construct a right angle triangle over here, this is Fy. This is a right angle triangle. Okay. Triangle O, let us say I'm putting here this as B. Triangle O, B, C. Let us say triangle OBC is this one. This is a right angle triangle. Then, what is tan theta in this case? In the right angle triangle, tan theta is what? Opposite side by adjacent side. Fy by Fx. Then theta is how much? Theta is tan inverse of Fy by Fx. This is the direction angle. This is the magnitude length of the vector. Okay. Now, when you want to represent a vector, the second way is vector form. Vector form. Along with its components. Along with its components. This is the second way of representation. Observe. Suppose, let us say, F bar is a vector. It is represented as, let us say, Fx I bar, where I is the unit vector along x-axis. Fx is magnitude of this force along x-axis. Here, I repeat, I is the unit vector along x-axis. Fx is magnitude of this force F along x-axis. Now, if I represent this is x-axis, this is y-axis, origin. Okay. The F is a vector along x-axis bar, where Fx I bar, and Fx is components along x direction, comma I bar is unit vector along x direction. That means it is acting only in the one dimensional, only in the one dimensional. One dimension. Acting in the one dimension. Here, fx. Suppose if I want to represent in the two-dimensional, in 2D plane, two-dimensional xy plane, if I want to represent, this is x-axis, this is y-axis, isn't it? Suppose this is the force F, and this is acting at an angle theta. Let us say its component along x direction is fx, and its component along y direction is fy. Then I bar is the unit vector along its direction. J bar is the unit vector along y direction. Then vector is represented as bar is fx I bar plus fy j bar. Where this force is, this F force having two components. The component is fx is magnitude along x direction. Unit vector shows the direction of the vector. Similarly, for F, the magnitude along y direction is fy, and unit vector shows its direction along y-axis, fy j bar. This is two-dimensional plane. Clear? And if I want to put up in 3D plane, let us say this is x-axis, this is y-axis, this is z-axis, origin. If I represent a vector F, like this, it is having component along x direction is fx, and unit vector is I bar, and along y direction component fy, unit vector is j bar. Along z direction component is fz, unit vector is k bar. Respective x-axis, y-axis, and z-axis. Here. Okay. Then the complete vector is represented as f bar, which is equal to its f's contribution along x-axis, fx, it is magnitude, and its direction is shown by unit vector I bar. F's contribution along y-axis, that is magnitude, and its direction is shown in the by means of z bar. And F's contribution towards z-axis, its magnitude, fz, its direction is shown by the k bar. Fx I bar plus fy j bar plus fz k bar. This is the 3D form of the vector. Clear? You can represent in the 3D form. We have seen 1D form, 2D form, 3D form of the vectorial representation. Okay. Now, observe, suppose, let us say, here, a vector A bar is given to I bar. What is the meaning of it? What is the meaning of it? 2 is magnitude along x direction, and I is the unit vector showing the direction along x. That means it is having only x direction. 2 is magnitude, I is the direction along x-axis. Clear? Suppose, let us say, a vector b bar is given as 2I bar plus 3j bar. Then what is the meaning of it? What is the meaning of it? 2 is the magnitude of b along x-axis, and its direction is by means of unit vector along x-axis. 3 is the magnitude of b along y-axis, and its direction is unit vector along y-axis. Clear? Ij stands for directions. 2 and 3 stands for magnitudes. Here I clearly write. These are magnitudes. Magnitudes are components of b bar along x and y axis, along x and y axis. I and j, they show the directions by means of unit vector. Is it clear? Okay. Similarly, if a bar is given as, let us say, 2I bar, 3j bar, and 4k bar, 2, 3, 4. All these are magnitudes. All these are magnitudes, are simply components. Components of a bar, okay, along x, y, and z axis. Okay, and I bar, j bar, k bar, they show the directions along x, y, z in the form of unit vector. Clear? Now, in general, a vector is simply represented as, observe it. Suppose a bar is a vector, then magnitude of a bar multiplied with the unit vector n cap, here I am showing unit vector along the direction. Magnitude of this a bar, modulus of a, and unit vector along the direction. And for this, if it is, for this, let us say, if it is one-dimensional, example I am putting 2I, magnitude, example only, and direction. If it is two-dimensional, let us say magnitude and directions. Magnitude, directions. Okay. If it is three-dimensional, magnitude, direction along x-axis, magnitude and direction along y-axis, magnitude and direction along z-axis, along the z-axis. Here, that means general notation. A bar is magnitude into unit vector along the direction. Clear? It's a general form of representation of a vector. I stop here. Hope you have understood how to resolve a force into components, horizontal and vertical components. Similarly, how to represent vector in the graphical form as well as in the vectorial analytical form, and also how to denote vector by means of a magnitude and unit vector. Thank you very much. If you like the video, please share it and subscribe it. Thank you very much.